Hello, welcome back to Matrix and Determinants. And today we start the applications of matrices and then the determinants. So the first one is the solution of simultaneous equations by matrices. So the procedure for solving linear simultaneous equations in two unknowns using matrix. So first of all, I want to deal with the two unknowns. What are the procedure in solving simultaneous linear equation using matrix when we have two unknown? Alright, the first procedure is to write the equations, the two given equations in the form a1x plus b1y equals to c1 and a2x plus b2y equals to c2. The second step is to write the matrix equation corresponding to these equations. So that is the above expression, just write it in matrix form. The coefficient, that is a1, a2, b1, b2. Then the unknown, that's your x and y. Then your result, you have that's your c1, c2. Okay, so the third step is to determine the inverse of your coefficient matrix. I mean the inverse of a1, b1, a2, b2. And don't forget, in our previous lesson we have checked out to find the inverse of a 2 by 2 matrix. That is, you find the determinant, which is a1, b2, that is this times this minus this times this, a1, b2 minus b1, a2. Then we multiply it with this matrix. We interchange this b2 and ba1. Then you find you change the sign of this order, which is we are going to have minus b1 and then minus a2. So you can check our previous lesson in order to find out the determinant of the inverse of 2 by 2 matrix. Okay, so step 4, you multiply so multiply your each side of 2 and this each side by the inverse matrix. And lastly, solve for x and y. By equating corresponding elements. Okay, so let's take this example and check this procedure one after the other. Example 1. Use matrices to solve the simultaneous equation. We have 3x plus 5y minus 7 equals to 0. Question 1. 4x minus 3y minus 19 equals to 0. Equation 2. So according to the rule, the first thing is to rewrite my equation. Go back. You can see is to write the equation in this form, whereby I take the constant to the other side. So I'm going to have 3x plus 5y equals to minus 7 cross this side. That will give me positive 7. Then 4x minus 3y equals to then minus 19 to the other side. That will be positive 19. Now, the second step is to write it in matrix equation. So the coefficient of x here, I have 3 and 4. And the coefficient of y here is positive 5 and negative 3. Then multiply it with my unknown variables x, y. Then also equate it to the constant 7 and the 19. So the next step is to find the determinant of this. Sorry, the inverse of the coefficient matrix 3, 4, 5 minus 3. So the rule is that multiply with the reciprocal of the determinant, and determinant will be minus 3 times 3. That will be minus, okay, let me write minus 3. 3 times minus 3 minus 4 times 5. Then it has changed this diagonal element. I have minus 3 and 3. Then change the sign of 4 and 5. That is minus 4 and minus 5. Okay, let me simplify it further. I'm going to have 1 over minus 3 times minus 3, that is minus 9, minus 20, that is 4 times 5. So I'm going to have minus 3, minus 5, minus 4, and then 3. And then lastly, I'm going to have minus 1 over 29 into bracket minus 3, minus 4, minus 5, and 3. So using that to open the bracket, I'm going to have, that will be 3 over 29, 5 over 29, 4 over 29, and then 3 minus 3 rather, minus 3 over 29. So that gives me the inverse of that particular coefficient matrix. So now I'm going to multiply each side of this with this inverse. Okay. So I'm going to have and don't forget, if I multiply 3, 5, 4 minus 3 with its inverse, I'm going to have a unit matrix. You can also check our previous class for that. 4 over 29 minus 3 over 29. Here xy. So we have 3 over 29, 5 over 29, 4 over 29, minus 3 over 29, 7, and then 19. So multiply each side with this our inverse of coefficient matrix. So if you multiply this with this, so that will give you a unit matrix. It should be 1, 0, 0, 1 times x and y. So don't forget your matrix rule, row by column. That will be 3 over 9 times 7, that is 21 over 29, plus 19 times 5, that is 95 over 29. So let me extend this. So 4 times this time this, the last row times the column, we have 28 over 29, 28 over 29 plus, sorry, minus 3 times 19, that is 57 over 29. So if we actually find the addition of this, we are going to have a final addition of this, that will be 21 plus 95, we have 6, 9 plus 2, that will be 11 over 29. Then if we subtract this, we are going to have minus 28 minus 57, 28 minus 57, that is minus 29 over 29. So don't forget 1 times this will still give me x and then y. So 116 divided by 9, that equals to 4, and 29 minus 29 divided by 29, that will be minus 1. So I can see that we have our result. So we have our x equals to 4, and then our y is equals to minus 1. So you can actually check the result and you see that it's actually correct. So that is how to solve make use of matrix 6 to solve two unknown simultaneous equation of variables. So in the next video we will be checking the using matrices to solve the unknown equation. Thank you so much for watching. See you in the next lesson.